the last clue for the 3 planet interior clues. And this is the last thing we're talking about today. So here we go. Clue number 3 is magnetic fields. The magnetic field of a planet can tell us a few things about the inside of that planet. So here's a first quick question about that. Give me an example of a planet that has a magnetic field. What's an example of a planet that's got a magnetic field? Any planet. Give me one. I'm sure you can think of at least one planet that's got a magnetic field. Yeah, the Earth. The Earth has a magnetic field, right? The Earth is an example of a planet that has a magnetic field, okay? So, you probably are aware that our magnetic field has poles, right? Do you guys know where the poles of the magnetic field are? Roughly? Where are the north and south magnetic poles of our planet? Yeah, they're pretty close to the north and south pole of the actual planet. So, like the rotational pole, the poles that we rotate around, you got your north pole, you got your south pole. The magnetic field of the Earth is actually a little bit crooked. And if you've, there have been a few news stories recently about how our magnetic field is slowly shifting around. And actually, well, I say slowly, but it's actually a little bit faster than it usually moves over the past couple of years. So our magnetic field can move around a little bit. But it has a very simple, basic shape. Okay? It has a very simple, basic shape to it. Somebody's asking, should we care about the shifting of the magnetic field? It probably would not be a problem. And I'll get back to that in just a second to explain why that's probably not a problem. But don't worry too much. You don't have to be afraid. There's so much other stuff going on right now. Don't worry about this. Okay? Now, that said, what is the shape of our magnetic field? The shape of our magnetic field is the same shape of magnetic field you get from a bar magnet. Okay? And what do I mean by a bar magnet? I mean a very simple type of magnet. Like, typically when people think of magnets, they probably think of something shaped like this. Right? With a north and a south. That's called a horseshoe magnet. A bar magnet is if you took this and straightened it out. Okay? So if we just had, a simple, basically a little metal rod with a north and a south, the Earth's magnetic field is going to have the same kind of shape as this thing right here, okay? Not this. Now, what does that look like? Well, if you want to get an idea of the shape of a magnetic field, you can do a little experiment that sometimes people do, like in grade school, middle school or high school, maybe even elementary school, it depends, where you take a magnet like this, and you take a sheet of paper, and on that sheet of paper, you sprinkle a bunch of little metal filings, right? You sprinkle a bunch of little metal filings all over a sheet of paper, and then behind that sheet of paper, you put the magnet. And when you do that, all of the little pieces of metal will line up with the magnetic field. And when you do that, it comes out looking like this, okay? Yeah, a few of you might have done that experiment in school when you were first learning about magnetic fields, or maybe any time. And where's my picture? Where are you? I lost my picture. Where's the picture I want? There we go. Sorry about that. It's a little bit of delay. When you do that, this is the shape you're going to get. So they've put a bar magnet behind this sheet of paper right here. And all of these are little pieces of metal. They were randomly scattered before the magnet went on. But when the magnet went on, you can see they kind of bunch up at both of the ends of the magnet, because that's where the poles are, right? But the rest of the page ends up following this kind of shape like this, where it pinches in the top and then also pinches in the bottom. So it turns out Earth's magnetic field, if you could somehow do this with the Earth, you would end up getting everything lining up in the exact same way. So see how this picture looks a lot like this picture right here? We've just replaced the magnet with the Earth right here. And you can see that our magnetic field goes into one pole and also the other pole. Of course, you have to think of this in 3D. Basically, our magnetic field is like a bubble around the Earth, but that bubble is pinched in the top and in the bottom. So it's shaped kind of like this. If you spun it, if you spun this all the way around, that would be the Earth's magnetic field, okay? Sorry if I went off frame, but hopefully you get the idea. Here's how I'm going to describe it. I'm going to say this a bunch. I'm going to say that the magnetic field of the Earth is kind of shaped like a pumpkin, okay? It's shaped like a pumpkin, because a pumpkin's roughly round, but it's pinched in at the top and it's pinched in at the bottom. So Earth has a magnetic field shaped like a pumpkin, okay? And that's the same shape that every planet that has a magnetic field is shaped like. It's always shaped like a pumpkin, okay? Now, what does that tell us about the inside of a planet if it has a magnetic field, okay? Now, number one, it has to do with how our magnetic field forms, okay? It has to do with how our magnetic field gets there. Because remember, just a second ago, I talked about how our magnetic field is not perfectly lined up and it's sort of shifting around a little bit. That means our magnetic field can move, okay? And every once in a while, does anybody know what happens to our entire magnetic field every once in a while? Like every few thousand years? See if you guys know. If it's related to it being able to move. So our magnetic field does weaken and strengthen over time, but what I'm getting at here is that every once in a while, it actually will completely flip upside down. It will shift, it will shift entirely over so that the north and south magnetic poles flip. And that's happened thousands and thousands of times, okay? And in fact, since human beings have been here, our magnetic field has completely flipped over lots of times. And did that wipe out all of humankind? Did the last time our magnetic field flipped all the way over, did that kill off all the humans? No, it didn't, right? It didn't kill off everybody, right? So that's why you don't have to worry about it. Our magnetic field has flipped lots of times, and we have lived through it, basically with no problem. Humans wouldn't have even known that that was happening, but by looking at the evidence in the rocks that make up our crust, we know that the magnetic field has flipped lots of times. Okay, what does that tell us? Let's see this. Here we go. What does that tell us? If I had my bar magnet, don't overthink this. If I wanted to flip where the north and the south poles were, what would I have to do to this bar magnet? If I wanted to flip where the north and south were on this page, what would I have to do to this bar magnet right here? What's the easiest way to flip this field? Yeah, spin the magnet, right? Rotate the magnet. Pick up the magnet, flip it upside down, and put it back in place, right? So here's my question. I just got done saying that the Earth's magnetic field has flipped thousands of times. Am I saying that the Earth itself flips over every few thousand years? Am I saying that the Earth flips over every few thousand years? Is that what I'm saying? No. That's not what I'm saying, right? And check this out. Remember I said that the magnetic field right now is shifting around? The Earth isn't shifting around, okay? if the entire Earth had flipped over, even ancient people would have been able to figure that out. Because if the entire Earth flipped over, all of the constellations would have moved. They would have flipped over as well. And that hasn't happened. The constellations have stayed in the same spot, even though the magnetic field has flipped. Other than that little bit of shift because of precession. So what I'm getting at here is that Earth's magnetic field can flip without the Earth itself flipping. And what that tells us is that whatever is making this planet's magnetic field, and all the planet's magnetic fields, must be something inside that can move. It means that it's not being made by the solid material of the planet. So if it's not being made by the solid material inside of our planet, what kind of stuff is it being made from? If it's not being made from our solid material, what might it be being made from? You guys are, liquid. Liquid. I'll read between the lines on what you guys are trying to say. It must be made by the liquid inside of our planet, okay? And so, we know that if a planet has a magnetic field, then that magnetic field is specifically a type of magnetic field that is formed from a type of dynamo. So if a planet has a magnetic field coming out of it, then that planet must have a dynamo inside, and a specific type of dynamo. In this case, what we're talking about is a rotating, conducting fluid. Okay? So let's make sure we understand exactly what I mean here. So like we just led up to, we said it's got to be a fluid or a liquid, right? Fluid just means liquid here, in this case. So it's got to be something that can flow. So a liquid. Conducting. Why is this word here? There's two different kinds of things that something can conduct. When we say that something can conduct, what are we saying that it can conduct? Give me at least one of them. Heat. Heat can conduct heat. Do you guys know what the other one is? Electricity. Okay. So which of those two, heat and electricity, which one of those is probably important for magnetic fields? Which one is probably important for magnetic fields? Conducting heat or conducting electricity? You might not know this one. And actually, it looks like somebody's actually on the right track. It's electricity. It's electricity. So right here, by saying conducting fluid, we're saying that a planet that has a magnetic field has to have some kind of liquid inside that can conduct electricity, okay? Now, why is electricity important? Something you might not know. Imagine you had a wire, like an electric wire, okay? And in that wire, like a piece of metal or something, let's say that there was electricity flowing in this direction. One thing you might not know is that electricity and magnetism are both very related. Whenever electricity flows, if you were to take a compass and put it really close to that wire, if that wire was not shielded, then your compass would be able to detect a magnetic field around this wire, okay? So it turns out that anytime electricity flows, it automatically makes a magnetic field. That's actually why, one of the reasons why we have to shield wires, because wires will create magnetic fields, and that can cause interference with other wires. This was actually a big problem with entertainment centers before we had good shielding, because you had a whole bunch of wires off the back. They could sometimes interfere with each other with their magnetic fields and cause things like static in your sound or in your picture. But the important thing is this: anytime electricity flows, it automatically makes a magnetic field. So what I'm saying is, if a planet has a magnetic field, what must be flowing inside of that planet? What's creating that magnetic field based on everything I've just said? What must be flowing inside of a planet if it's got a magnetic field? Yes, you've got to have electricity flowing. The fact that Earth has a magnetic field tells us that there must be electricity flowing inside of our planet naturally, okay? And in fact, it would have to be a lot of electricity. It's too bad that this electricity is flowing so deep in the planet, because if we could somehow tap into it, it seems like maybe we could have a nice source of electricity. I'm not an engineer. I don't know if that's the good idea. But it's way too deep for us to ever do, unfortunately. Now, why is there electricity flowing in our planet? It's because of this last word, rotating. It turns out, if you've got a conducting fluid, like water, for example, water can conduct electricity. That's why you don't want to go swimming when there's lightning out, because if the electricity hits the water, it can conduct that electricity into your body. So, if you have a bucket of water and you spin it really fast, it will naturally just start creating electricity. If you take a fluid that can conduct electricity and you spin it fast enough, if you get it churning fast enough, it will naturally start to create electricity, and then therefore a magnetic field. So, what we're getting at here is that any planet that has a magnetic field inside, it must have some kind of rotating conducting fluid, okay? That's why the magnetic field is a clue as to what the inside of that planet is. Now,